My fans out there, good day. I remain Dr. D. I. June, your chemistry lecturer on social media. In my previous lecture, we discussed on the heat of fusion. From there, we graduated into sublimation. And I told you when heat is applied, a substance, particularly solid, and the solid, instead of melting, will just go into the gaseous state. That process is called sublimation. We give an example of iodine. When heated, will go straight from the solid state to gaseous state. Now, diamond also is a solid. But when diamond is heated, diamond does not form any because the atoms are too great to be overcome by vibration. Let me repeat that statement. Diamond does not melt. Because I'm bringing these things because as we further in our lectures, these things will come back. So you get a prior knowledge of them first. Now, if I ask you why does diamond not melt when heated, because the force of attraction is covalent. They are covalent bonded, and the atoms are too great to be overcome by vibration. So at a very high temperature, some carbon atoms break away by sublimation into the gaseous form. All right. So now, what we discuss today is now evaporation. Evaporation. Evaporation is the process of vaporization. Vaporization. Evaporation is the process of vaporization of liquids at all temperature, even at zero temperature. Substances can still vaporize. So particles in a liquid, for example, are equally what attracted by the neighboring molecules or neighboring particles in all directions, either to the right or to the left, to the front or back. So each particular particle is surrounded by neighboring particles or molecules or atoms. So those at the surface of the liquid are attracted inwards and sideways by the neighboring particles. Look at it now. If this is a container and you have water and it's liquid now, like this, see the particles there. You will see that some are this level, some are this level. We're not saying that the particles at the surface side, which is at the top side, are being attracted and pulled downwards by those particles that are below. Equally, they can be pulled to this side or to this side equally. That's what they're talking about. So, now, in evaporation, the molecules that near the surface of the liquid acquire extra kinetic energy. See, those that near the surface will first of all acquire the extra kinetic energy, and what happens? They will begin to break away from the cohesive forces that is binding them together. And once they become free, they escape into the atmosphere from the liquid surface and become molecules in the vapor state. And this explains why the volume of water decreases. When you boil, now if you apply, this is water, if you apply flame, heat here, and water begin to boil, after a time, you see that the volume will be decreasing. The reason is that as the vapor is taking place, it means that it is the particles that were there before are now going off from this container. So the tendency is that the volume here will begin to decrease. And that's when you boil water in a container, either on your gas or your stove. After a time, the water begin to go down and eventually finishes from the container. So since evaporation results in the escape of energetic particles from the liquid body, the average kinetic energy of the liquid is lowered. It's lowered. Now, this results in what? Drop in temperature of the liquid. Evaporation of a liquid occurs at all temperatures, but the rate of vaporization increases with increase in temperature. The rate of evaporation also depends on the type of liquid. Listen again. Let me take this once again. One, that the evaporation of a liquid occurs at all temperature. It's not only when you heat up. At all temperature, evaporation can take place. Then we say that the rate of evaporation increases with increase in temperature. So if we increase the temperature of the substance, then the rate of evaporation will also increase. Now they will say the rate of evaporation also depends on the type of what liquid. For example, now if you have a basin of water and you have a basin of fuel, like petrol now, they're all liquids. If you expose them to the sun, equal volumes, and give them 3 hours, when if you go back, the level of evaporation from the petrol will be higher than as compared to the water. You see? So evaporation increase or the fastness also depends on the type of liquid that it is. Now, if you now put three, let's say you have oil, the red oil, or diesel, or petrol, and water, this is for them, equal volume of them in container and put them and allow sun to heat them for 3 4 hours. If you go and look at them, the volumes they are going to obtain from them will not be the same again because of what? Evaporation. Because right from the time till that 4 hours, many of the molecules are escaping from the top layers of the liquids as it may be. So, like it, comment, and share this video. Please also subscribe to my YouTube channel. Thank you.